Hi, so we are moving on to the different regions of the periodic table. And the first way that we're going to break up our periodic table is into a section of metals, a section of nonmetals, and a section called metalloids. So you're going to want something to color your periodic table with in your notes. So maybe 3 colored pencils or highlighters or just something that you can distinguish the 3 areas of the periodic table. The first thing that we're going to do is highlight an area that is called the metalloids. So metalloids are elements that have properties of both metals and nonmetals. And if you look at your periodic table, you'll notice on the right-hand side, there's a bolded line that looks like a staircase. This line separates the metals on the left from the nonmetals on the right. But the elements that touch that staircase have properties in between, and we call them metalloids. So you want to color in every element that touches that staircase with the exception of aluminum. And now we can color in all the other elements as metals or nonmetals. Everything to the left-hand side of the metalloids is a metal with the exception of hydrogen. We'll talk about hydrogen's specific properties in the next video. Hydrogen is appropriately placed above lithium, but there's also many reasons why. You could also put hydrogen above fluorine on the right-hand side of the periodic table. For the purposes of this exercise, we're going to count hydrogen as a non-metal. So we're going to color it whatever color you decide to color the non-metals. So everything on the left-hand side is a metal except for hydrogen. And now we can color all of the nonmetals our last color. So hydrogen and then everything to the right-hand side of the staircase. So now that you have the periodic table color-coded, we can actually talk about some of the properties of these particular groups of elements. So what would be some of the properties of metals? Well, a lot of these are going to be properties that you may already know, or things that you already know about metals. So, when we think of a metal, think of like copper or iron or nickel, something like that. All metals are shiny, they're malleable and ductile. They conduct heat and electricity. So let's write down some of those properties. And malleable and ductile may be new vocabulary words for you. Malleable means that it can be hammered. Think of the word mallet and malleable. Those come from the same root. It can be hammered into a thin sheet. So if you were to take something like a block of ice and you were to hit it with a hammer, it shatters into 1,000 pieces. That's not malleable. If I take a piece of metal and I hit it with a hammer, it just flattens. That's malleable. Ductile is similar. Ductile means that it can be drawn, that's the word we use, into a wire. If you can make it into a wire, that substance is said to be ductile. couple other properties of metals is that they're all solids at room temperature with the exception of mercury. Mercury's abbreviation is Hg. And the other property of metals, and this is going to become important as to why all of these properties are there, is that the metals tend to have 1 or 2 or 3 valence electrons. And because of that, they will lose those valence electrons and become positive ions, which we're going to learn are called cations. So those are some of the properties of metals. Now, when we talk about the properties of nonmetals and then the properties of metalloids, you'll find that we don't have nearly as many properties of nonmetals. And if you look at the periodic table, there's much fewer elements that are considered nonmetals than metals. And most of the time, what we say about the properties of nonmetals is that they are not the properties of metals. So first thing you may notice, you may know already, is that instead of metals being all solid at room temperature except for mercury, at room temperature, the nonmetals can be many different states of matter. There's many of them that are solids at room temperature, many of them that are gases at room temperature, and there's even one, bromine, that's a liquid at room temperature. And basically, we're going to say that the properties of nonmetals are the opposite of the properties of metals. They are not malleable, not ductile. They don't conduct electricity and heat. And also the opposite of metals, they don't lose electrons. They tend to have a lot of valence electrons, 4, 5, 6, 7, 8. And because of that, they tend to gain electrons in order to become stable, which means that they form negative ions or cations. So cations, we'll go over this vocabulary in another video. Cations are the positive ions. Metals form cations. Nonmetals form anions, negative ions. And then there are the metalloids. And now the metalloids have properties that we would say are in between the properties of metals. Oftentimes it can be what it's bonded with will determine its properties, or even what temperature it is may determine whether it acts more like a metal or more like a nonmetal. But one really important property of the metalloids is that they are what we call semiconductors. You may have heard that word before. So they conduct electricity, but not as well as metal, but not as bad as a nonmetal, literally in between. Because of that property, they've become fairly important in electronics. So when you hear of like Silicon Valley as a place where there's a lot of high-tech software, hardware companies, it's not called Silicon Valley because there's a lot of the element silicon there. It's because many of the companies there are high-tech companies that deal with printed circuit boards, which involves the element silicon. So those three major areas of the periodic table, metals, nonmetals, and metalloids, can help us to give some general properties of elements. And what we're going to do now is we're going to color in the periodic table again, this time getting a little bit more specific. So breaking up the metals into different groups of metals and different groups of nonmetals. So this time you're going to need many more colors. I think we use 8 total colors to color in the periodic table in our next video. So get those colored pencils or highlighters or crayons or markers, whatever you want. Get those handy for the next video.